Okay, question 5 should be quite clear that this is a wave function question. So I've just put the expansion formulae over here. Don't forget to use them. And just to remind us, when we do a wave function, we're putting cos and sine together. So two waves. You imagine in a pool, you've got two waves coming together. What does it form? It forms another wave, slightly bigger. So that's all we're doing here. Okay, where k is how much bigger it is. This was obviously the max and min of this wave, 3 and -3, 5 and -5. So how big is our wave going to be? Yeah, and we use Pythagoras for that. And we can obviously say it's a sine wave or a cos wave because they're the exact same. They're just, shifted 90 degrees, hence the word cos. That's the complement of sine. Complementary angles add up to 90. So you could, write, that's why we can write it any way we like. We can do a sine plus or negative or a cos plus or negative expansion. You're just kind of looking at the wave at a different point, So that's a bit of background which we don't need. The point with this is it's very formulaic. Okay, so the first thing I would do is write down my expansion. So we're going to expand. We're going to expand k sine of t plus alpha, or a, whatever you want to call it. So if I expand that, I'm using this expansion formula here. So the sine, it goes k, now the k just stays in front, don't worry about the k, k sine and cos, and then it's cos and sine. This is how I write it when I do it. The plus for the sine stays the same. This just means that plus gives you plus, whereas with cos's, plus would give you a negative. So I know I've got a nice plus in here. And you've got AB, so I'm going to have T alpha, T alpha. So that's kind of how I write it just when I do the expansion, right? Now I'm just going to rearrange it slightly. I want to move these alpha terms to the front, okay? So I'm going to have K cos alpha sine T. So I'm moving the cos alpha to the front, and that's just so that I can equate it, and I'll show you that in a wee sec, plus K sine alpha. So again, this sine alpha has just moved to the front, cos t. Apologies for this big gap. I probably should have just, yeah, that's a times, by the way. I probably should have just had them sort of close together, but just that's the way I write it when I do it. It just helps me not make silly mistakes. Okay, I like doing it. So now, well, we said that this is the same as this, so I'm going to write the original function below. So I'm going to say, okay, well, I had 3 cos t plus 5 sine t, and then I'm going to try and equate top and bottom. Now, right now, they've tried to trick us. Look, these don't quite match up. So what I'm going to do is I'm going to write that round the other way. Okay, I'm actually going to, just to help you out, just to show what I'm doing, and for future people who might watch this, I'm going to write 3 cos t plus 5 sine t. I'm going to write it over here. Is the same, obviously, as just putting it round the other way. So that's 5 sine t plus 3 cos t. Now it starts to look the same. Look at that. Everything's lining up. Yeah, so sine t, cos t, pluses, brilliant. So that means that k cos alpha has to equal 5, doesn't it? If I'm saying that this, which is the same as this, is equal to this. Yeah, so that function is the same as this function. So this bit here has to be 5 to give me 5 sine t. The 3 here has to be the same as k sine alpha because we've got the cos t there, so 3 in front of it. Brilliant. So that's me done my expansion. Fantastic. Now I'm going to work out my k value. In fact, I'm going to do my alpha value first. I'm going to do alpha. It doesn't really matter what you do first. I'll just do alpha. So my alpha value is saying that k sine alpha is equal to 3. And make sure you explicitly write these, okay? And k cos alpha is equal to 5. You have to explicitly write them. And then I'm going to say, well, k tan alpha, sorry, just tan alpha, is the same as k sine alpha over k cos alpha. We know that, don't we? Sine over cos gives us tan, and those k's will cancel out. So then I've got 3 over 5. That's brilliant. So then alpha is going to be equal to tan negative 1, 3 over 5. And are we doing this in degrees or radians? Do it in degrees, okay? So make sure your calculator is in degrees. Mine is not from that last question. There we go, degrees. So 3 divided by 5, shift tan or inverse tan. That will give me 30, and I'm going to, I'll call it 30.96 just to be super duper accurate. Okay, I think 1 decimal place would be okay, but yeah. Okay, so that's me, you got that. And I'm just going to double check the quadrants for this as well. When everything lines up positive, it's quadrant 1, but just, you might as well just show it, just a peace of mind, So sine's positive, cos is positive, and tan is positive. So where's sine positive? Here and here. Where's cos positive? Here and here. Where's tan positive? Here and here. So it's quadrant 1. So this is the right answer. We would have just changed that value depending on which quadrant we're in. If we ended up with a negative somewhere, if sine was negative, we'd be saying, all right, where's sine negative going to be? Well, sine negative be here and here. And a negative sine would end up giving us a negative tan. Do you know what I mean? So then it would be here and here, etc. So just watch out for that. So that's me got alpha. And I'm going to get my k value. And k is just a bit Pythagoras. It's just saying that k is equal to the square root of 3 squared plus 5 squared. So we've got 9 plus 25. So it's the square root of 34, which is, I'll just leave it as root 34, will I? Yeah, that'll be nice. And then we'll do our final answer. So I'm just going to put that all together. So root 34, that's my maximum min, isn't it, of my wave function, the number in front, yeah? And then I've got, was it t we said? T plus 30.96. So that's the movement. That's saying our wave has been moved to the left 30 degrees. Okay? So let's just check our marking scheme, see where we're getting our marks from. Yep, you get a mark for just doing your expansion, which is good. So using your angle formula, yep, very nice. You're getting a mark then for this bit here, saying it's 3 and 5. You're then getting a mark for your k, and then a mark for your final answer with the angle in there as well. So, actually this bit here, there's 3 marks available for this. This is only worth 1 little mark, this whole bit here. So yeah, not bad. The next part of the question, state the minimum and determine where that occurs. So I'll just zoom out a wee bit. And I'll move over here. So that was 5a. So now 5b, state the minimum and where does that occur? So root 34 sine of t plus, already forgotten it, 30.96. So the maximum and the minimum is this number here, yeah? So the max would be root 34, and the minimum would be negative root 34, FYI, okay? Just the same as we've been doing that since standard grade, haven't we? The National 5, the first number is the peak of your wave, and it's asking, well, where does that occur? So what we have to do is say, well, I'm looking for, don't forget, this is effectively y equals, isn't it? So then I'm saying, well, when my y is negative 34, root 34, can I solve that? You're just putting in a value for y, and we'll go back the way to work out. So quite straightforward. If I'd given you something that said, negative 1 is equal to 2 sine x, I could probably get a third or fourth here to solve that. You'd be saying, yeah, I'll divide by the 2. Fantastic. Shift sign. Brilliant. Okay. And we're just doing the same. Don't be confused, because we've got all these extra, surds and shifts and things. I'm going to divide by the root 34 first of all. So that just becomes negative 1 sine of t plus 30. Yeah, absolutely. And that makes sense, doesn't it? You're saying, well, when is my sine function at its absolute minimum? The OG sine function, goes up to 1 and down to negative 1. Yeah, so it doesn't really matter if, mine is root 34, negative. It's still that same, ratio, like that. So we've got that. So I'm saying, well, where is sine? So I'll do sine, inverse sine of negative, technically do inverse sine of negative 1, 1 is equal to t plus 30.96. Okay, you're kind of doing that, aren't you? Because remember, we would always do inverse sine of the positive and work it out. But I don't quite even need to do that, because I can just look at my graph and say, well, I'll draw this bigger actually again for the next people. Someone's not listening. You're basically saying, where is your graph negative 1? Well, it's negative 1 at 270. So I don't even really need to do, to use my calculator for that. Yeah, so it's, you could do shift sign of 1 and then look at your quadrants, where sign negative and stuff, but it's easier just to do, okay, well, it's negative 1 at 270 degrees. Yeah, and then we're just rearranging to make